if there is two objects having mass m1 and m2 and the distance between them is r, these two objects will always attract each other, and this force of attraction is directly proportional to m1 m2 and inversely proportional to the distance square. So here we can write F is proportional to m1 m2 by r square, and this F we can write equals to G into m1 m2 by r square. What is G? G is universal gravitational constant. Its value is 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus 2. Now, if this is Earth and there is an object on Earth, suppose have mass m, then it will feel the force of attraction due to the mass of Earth, right? And that is what we call the weight of the body. So let's see this now. So if there is an Earth or there is an planet, suppose it has mass big M, and there is an object, it has mass m, and the distance between them is r. So you can write F is equals to G into m big M by r square. Now what is force? Here the force will be force of attraction, its weight, right? Its weight. So its weight will be mg. What is G? G is gravitational acceleration. Okay, acceleration due to its gravity is equals to G mm by r square. So this m is cancelled. So G is equals to G m by r square. So this is the gravity on the surface or near the Earth. So as you see, as the r increases, as the height increases, G decreases. As the height increases, G decreases, right? So G on Earth is 9.8 meter per second square. Now suppose this is what? This is Earth, okay, Earth or a planet, and the object is at height h from the surface of Earth. Okay, so if the object is at height h, we can write G is equals to G m by r plus h square, right? What is r? R is radius of Earth. And what is h? H is height of object from surface. Okay, so you see, if the height is very small, we can neglect the height and consider the distance between the object and the planet as its radius of the planet. Okay, but if the height is big enough, then this will be the acceleration due to gravity on the object if the object falls. Okay, now you see, if g is equals gm by r square. What is m? M is mass of the planet, and you know that mass is density into volume by r square. So here you can write g rho, volume is 4 by 3 pi r cube by r square. So this r square and cube cancel, so we can write g is also equals to g rho 4 by 3 pi r at earth. This is at height h. Okay, this is at e. So this is also another expression. Okay, now let me show you another thing. So we find out that g at earth is 4 by 3 pi g r rho, right? So if we go inside the planet or earth, if this is g, okay, if we go down inside, then what it will be? G at depth of d, we can write 4 by 3 pi g r minus d by rho, right? This is r. Suppose this is the planet and we went under, we dig down and go here. So here what will be the gravity? The gravity will be this, will minus the depth. Okay, suppose if this is the depth, okay, then will minus from radius. So you see here g is proportional to radius, right? So this is the acceleration due to gravity. We found that g at earth is gm by r square. It is also equals to 4 by 3 pi g r rho, and g at height h is gm by r plus hs square, and g at depth d will be is 4 by 3 pi g r minus d rho. For depth we consider this expression, and for height we consider this expression. So these are the important formulas you need to remember, and I hope you understand this video, and I will meet you in my next video.